So, we're going to have a bit of a recap of where we're at in philosophy and what we've been talking about. And then we've got three other arguments that we're going to look at today. I would like to look at three, but I'm going to gauge how you guys are going with it because it can be, I think these are probably the easiest three arguments, but still, we don't want to overwhelm you. So, we're talking about philosophy, right? Philosophy is about truth. And within philosophy is the subset of metaphysics, all right? And that's about the nature of reality, Taj. And one of the questions of metaphysics is about the existence of God, right? And we're not looking at it in a religious sense. We're not trying to look at it through a Christian or Islamic or Judeo sense of God. We're trying to look at God in what we call a philosophical sense. That is like a creator. And it's funny, like I find in this class and in other classes, and even just people you talk to, lots of people are really reluctant to use that word, God. They don't like that word. And they don't like that word because it does have religious connotations, right? It does have all of this religious baggage that goes with it. Or if you believe in God, that means you have to believe that Jesus rose from the dead. Well, that's not necessarily true. There are lots of people that believe in God but would reject Christian form of theism, right? So, when we talk about God in a philosophical sense, okay, God in a philosophical sense, these are generally the things we attribute to him. Omnipotent, that is all-powerful, can do anything, all right? Omniscient, so all-knowing, knowledge being a form of power, so that flows from it. Simple, all right? And so that means not composed of parts, all right? So immaterial obviously flows from that because parts are material things. Eternal, outside of time, so not bound by temporal constraints like we are. The source of all being, like all things that exist, derive their existence from God. And then this last one, I've drawn a line there intentionally because some people will say God is good. Other people will say God is not good, therefore God does not exist. But that can be a mistake because you could say maybe God's not good. Maybe he doesn't care whether you suffer or not. But there's still a being that created the universe as such. So that's a possibility. Some people tack on omnibenevolent, that God is good, and they're generally the religious understandings of God. Others, you know, we don't have to have it. I don't mind either way. So let's talk about the three arguments we've looked at so far. Definitely with the Year 11s, we looked at the Kalam argument. All right? And the Kalam argument, you might remember, Bradley, it says, you're here right now in this room at this instant because of all of the previous events. And you can think of it like a series of dominoes going back to the start of the universe. And it says the universe began, things that begin to exist have a cause, the universe has a cause. All right? What kind of thing could cause a universe to exist? And the Kalam argument says God must have caused the universe to exist. That's the Kalam argument, right? So we can see that one going back through time. Contingency, I haven't spoken about with the Year 11s as such, that's more of a Year 12 argument. And that one is like, why, this is it in a nutshell, maybe you've had this thought before. Why does anything exist at all? Because things don't have to exist, the universe doesn't have to exist. You can just as easily conceive in your mind of nothing existing. All right, it seems the universe is contingent, that is, it depends upon something else for its existence. It derives its existence from something. So that's the argument from contingency in a nutshell. And then we have the argument from motion, which is the one Father Oleg talked to us about, and that's quite a complex one. So if you want to talk about that a bit more, I will with you, but only to say it says, for any change to occur, it requires the actualization of potential. That can't go on forever. There must be something purely actual that allows all change to take place. So those were the three arguments. We've looked at Kalam, some of you looked at contingency and motion, quite challenging. Today then, we're taking a different track. They're called cosmological arguments because they're about the universe as such and properties of the universe. What we're going to look at today are called design arguments. And because what they say is there is evidence of design in everything we're surrounded by. It looks like it's designed, and if things are designed, they require something to design them. Okay, so they're the design arguments. And we've got three we're going to look at. We've got the argument from order, the argument from fine-tuning, and Paley's watchmaker argument. And we'll do them in reverse order. We're going to start with Paley's watchmaker argument. And this argument's written about 200 years ago by a philosopher, scientist called Richard Paley, or Edmund, I can't remember, Edmund or Richard, one of them. And he says, imagine you're walking along the beach. Who likes to go to the beach? I like the beach. Excellent. Everyone likes to go on the beach. And you see a watch in the sand. All right? Now you would automatically suppose that this watch was created by someone in a factory somewhere, or maybe it's a sort of a custom-made watch. But you look at this complex mechanism and you say, that is created. Watches don't spontaneously form out of sand and combine. You don't see complex phenomena just all of a sudden generating themselves out of sand. That has a creator. And so Paley says, if you think that of a watch, a simple mechanism, human beings are infinitely more complex than a watch. Human beings are infinitely more complex than a watch. So if you suppose the watch has a creator, Paley says, then so do human beings. Okay. What's a response? What's an objection?
Value.
Value?
Yeah.
Yeah, would you elaborate on that before we go for it?
It's like, like the value thing, it's like the watch doesn't have the same value as you are because it's created by humans, so it's emphasizing that humans are also like the
Excellent.
creators.
Yep, so humans have a value more than a watch. They're sort of a living thing, whereas a watch is just a mechanical object.
Yeah.
Yep. Yeah, and so he's making an argument by analogy though, isn't it? It's saying, this is complex, but you are way more complex. This obviously has a creator because of how complex it is. It doesn't spontaneously generate. How can we say the same about humans? They can't have spontaneously generated. They must have some designer. That's what he's saying. Okay, so it's written 200 years ago. All right, and let's try and think of what's some science that's developing around 200, 150 years ago.
Evolution.
The theory of evolution. Okay, it's a beautiful, beautiful theory developed by Charles Darwin. Okay, and so he travelled the world and he's looking at the fossil record and he's looking at all the different species, and he generates this beautiful theory that accounts for the emergence of complex life, complex phenomena. And this is it in a nutshell. So I've said this to the Year 12s last week, I'm going to say it again. So this is for the Year 11s. This is how evolution works, right? We've got here 3 mice. Okay, I'll use the same example because it's a great way to explain it. We've got here 3 mice. They're brothers and sisters, right? But this one's the fastest. If they were to have a race, this one will win the race. This is going to come second. This is going to come third. Okay, along comes a snake. Which mouse is going to survive?
Fastest.
The fastest one, okay? The fastest one survives. These other 2 get eaten by the snake. The fastest one survives. The fastest one gets it on, has a mate, has 3 baby mice. Okay? Out of those 3 baby mice, they're all descended from the same parent, but the same thing occurs. One of them's a little bit faster than the others. Which one's going to survive? The fastest one again. Evolution, natural selection works by if something provides a survival advantage, it helps you survive, then that is what's going to be successful. Here, speed helps the mouse survive, so it gets passed on. The fastest survive. The most fit, the fittest, all right, means those with the characteristics most adapt, most suitable to survival are the ones that are going to pass on their genes. And so you can see here, this is how they explain things like an eye. Eye. What a complex thing your eye is. But what they say is, at some point in time in evolutionary history, there was an animal that had a patch of skin, so it's a random mutation, right? Occurring at the genetic level, at the DNA level. And what's happened is that it had this patch of skin that was sensitive to light. And it endowed this creature with survival benefits over the rest of its kin. And so it survived. And because it survived, that mutation survives. And then each generation, you can imagine it getting stronger and stronger and stronger. And so from the theory of evolution, you can say, yep, we can account for the development of all these complex things, all right? Humans didn't spontaneously form. They've arisen out of this massive temporal phenomena of evolution. They've arisen out of all of these tiny, 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 tiny changes until you have this really complex machine of a human being. And that is a great way to account for complexity. Okay? There are still a couple of problems with it though. Is that, like, according to evolution, every single living thing on Earth is descended from one piece of bacteria. Okay? So you, me, the trees out there, the sharks in the ocean, every living thing has evolved from that first piece of bacteria. Alright? Now, we can make watches, we can manufacture watches, we can manufacture machines that make watches. But we can't manufacture life. Alright? We haven't been able to create that first cell of bacteria yet. Alright? And so we're constantly supposing, what was it that got it started, you know? And theories are there's these amino acids in the ocean shuffling together that somehow produce a living thing. Alright? You think of the chances of that occurring, a living thing. But it's not only a living thing, it's a living thing that can replicate itself. That divides. Alright? That copies itself. So you think of the improbability of generating something living, and then the improbability of generating something living that replicates itself. Okay, so incredibly improbable. What's an objection to that mathematical claim? The universe is enormous. There are stars everywhere. There's bound to be somewhere in the universe that it happens. And so this is like that's a law of mathematics, is that given an infinite number of tries of anything, if I was to walk into the wall an infinite number of times, if I had an infinite number of tries, eventually I would walk through it. Every event is possible given an infinite number of tries. And the reason is, it's because the atoms would shuffle themselves in such and such a way that would allow me to pass through it at some point in time. All right, it's incredibly improbable, but given enough tries, all of those things can occur. All right, so that's so that's Paley's watchmaker argument. I did have something else I wanted to say about that. So we said we've got evolution. Maybe there's an infinite number of tries, and so this is the mathematics that's still going on, right? It's incredibly unlikely. What's the probability of it occurring at random? How many trials do we actually have? Do we have an infinite number of trials, or is the universe finite? So they're one of the questions that remains. Now there's a joke about this. You can even imagine, right? Imagine the day, this is appealing to the contingency argument. Imagine the day when a scientist is able to get some dirt and rub it together and generate some living thing. All right? That the scientist has created life as such. And there's a great joke I like, and the scientist goes to God and says, God, we don't need you anymore. We don't need you. Look, I've created life. And God says, oh, why don't you show me how you did it? And so the scientist goes to pick up some dirt, and God wags his finger, get your own dirt. That's my dirt, you know. So it insinuating that all things that exist derive their existence from God. Okay, so that's the first argument. It's a pretty strong argument, but there are critiques of it as well, and we can see it ends up in some complex mathematics. Any other comments about the first argument, Paley's watchmaker argument? Argument from design. So to summarise, says you're walking along the beach, you find a watch, you assume it has a creator. Why wouldn't you assume the same about human beings? We can account for humanity through evolution. We can't account for this though, because we can make watches, and so this first living thing infinitely more complex than a watch, right? Okay, so let's look at the next argument, which is that of fine tuning. And this requires us to look at and have a scientific understanding of the universe. In the universe, there are what we call 4 fundamental forces that govern everything, okay? When we did determinism, we said all atoms are dictated by the laws of nature. These are the 4 forces that dictate the movement of all of the atoms. The first one we're very familiar with. We're familiar with gravity. It's what keeps you to the planet. The law of gravity, as postulated by Newton, says every piece of matter in the universe pulls on every other piece of matter. Every single piece of matter. And so the Earth is almost like one big composite of matter, and you're another body of matter. And when you jump up in the air, it's not that the Earth pulls you back down, it's that you pull the Earth and the Earth pulls you. It's just that the Earth is heaps more massive than you. That's why it looks like you're the only one that's moving. So every piece of matter exerts a force of attraction on every other piece of matter. All right, electromagnetism. All right, we've got strong nuclear occurring in the atomic structure of a atom, and we've got the weak nuclear force as well. So they're the four forces that govern everything. Now the argument from fine tuning says these forces are like dials. They could be any number. This is the gravitational constant, 6.67 times 10 to the minus 11. If you do stage 1 and stage 2 physics, that's a number you need to know off by heart. Okay? You're going to know that number off by heart. And here I've written it out as a decimal. All right? We've got 11 zeros. We'll put the decimal after the first one. So that's what that number is. That's the gravitational constant. The argument says if any of these all of these numbers are set like that, and if any of them were slightly different, the universe as we know it couldn't exist. So I've got a table here describing it. Jake, do you want to read the first row for me? So force, gravity, if it's stronger,
universe would have collapsed in upon itself, and if it was weaker, no planets or stars would ever
coalesce. Coalesce, yeah, very good. Okay, so gravity, the force of attraction. If it was stronger, Big Bang, contracts straight away. Gravity's too strong, sucks everything back together. If it was weaker, spreads out, nothing coalesces, stars do not form. All right, so that's just gravity. All right, if it's a degree higher, if this is an 8, all right, too strong, Big Bang fails. If it's a degree smaller, 6, too weak, everything just spreads out and nothing forms. All right, it is set perfectly for the emergence of stars, and as a result, high order atomic structures. All right. So I said to you, you guys are mostly made of carbon. All living things are predominantly carbon, and carbon is literally cooked in a star. That it requires the forces of gravity within a star. You think of the immense amount of pressure smashing hydrogen atoms together. All right. What's a hydrogen atom? It's like 1 proton and 1 electron. All right. So, and then in a star, those are getting smashed together, and that's how you get carbon, which is what? 16. It's got 8 protons. Okay, so that's gravity. Let's have a read of electromagnetism. Harry?
Electromagnetism. If it's stronger, the electrons heavily bound to atoms, no formation of chemical compounds. And if it were weaker, atoms would disintegrate at room temperature, not enough attraction between electrons and the nucleus.
Okay, same thing. I haven't written the electromagnetic constant out here, but you can see slight variation in it. It's going to have the same effect. We're not going to be able to have chemical compounds formed, and here atoms going to disintegrate. All right, how about strong nuclear? Can I get Bradley? Can you read that?
Strong nuclear. If stronger, all hydrogen would be converted into heavier elements. No hydrogen means no stars. If weaker, no elements other than hydrogen would have formed in Big Bang.
Very good. So with the fine-tuning argument then, you can think of these dials, right? Who's heard of the Goldilocks zone before? Has anyone heard of that, or can tell me what it means? Harry?
Well, it means the absolute perfect zone where everything is perfect and works exactly perfectly.
Very good. Can you describe where it comes from?
No, I cannot.
No?
It's the planet being like evenly distanced from the sun, as it's not too cold or too hot, and it's sustainable for life.
Perfect. So the story of Goldilocks and the 3 bears, right? She can't eat the porridge because it's too hot. She can't eat the other porridge because it's too cold. She finds the one that's perfect. The same is said for like planet Earth, right? It's in what we call the Goldilocks zone, which is the optimal distance from the sun that allows for water, and all life on Earth requires water. And so planet Earth is in the Goldilocks zone, you know, and so that's one thing you can say about planet Earth. But this is not making it about the claim of our solar system, it's making about the numbers that dictate the laws of our universe. It's saying these numbers are in the Goldilocks zone, and a slight change to them is going to have drastic effects. It's going to stop all life on Earth from in the universe from occurring. It's going to stop anything from forming. So that's the argument from fine-tuning. Now, there are some ways of pushing back against that. Any ideas? All right. One of them is, sorry?
There's still a chance of having that if there's infinite possibilities?
Yep, if there's infinite possibilities, very good. So there's a theory of cosmology that asserts there are an infinite number of possibilities. It's called the multiverse hypothesis. And it says our universe is one universe in an infinite number of, in a multiverse, where there's an infinite number of other universes. And if each universe has different properties, then you can account for the reason these are set the way they are. All right. What evidence do we have for a multiverse?
Different galaxies?
Well, they're in our universe. They're part of our universe. So yeah. Could we ever observe evidence of a multiverse?
No.
No, because it would be within our universe, right? Yeah. So it's not something that we can observe, but it is something that we can postulate. So that's sort of a response to fine-tuning, being the multiverse hypothesis, and there's some responses to that. Okay, last one is what I call the argument from order. And I probably think this is the strongest one myself. I think the other two are reasonably strong, but I think this is the strongest one. And it relies on what we call the second law, Taj, of thermodynamics. This is called entropy. Entropy, this is an important word. And what that says is the universe moves from a state of order to a state of disorder. And you see this around you all the time. Other ways it's described, disorder is more probable than order. All right? Energy dissipates. I've just thought of a good way to explain it. And explain order, right? So up here, I could have colours arranged in a rainbow. Who can tell me what are the colours of a rainbow? What order do they go in?
Red.
Red, orange, yellow, green, blue, indigo, violet. Roy G. Biv. All right? Roy G. Biv. Those are the colours of a rainbow in order. Now, how many possible ways are there of arranging this sequence of letters? All right? I could have, I could swap the O and the Y and keep this the same. I could swap the I and the V and keep this the same. So there are, you can see there's lots, and we can determine that mathematically. If you do Year 11 methods, you'll do that a bit later in semester 1. But there are lots of ways of rearranging this series of characters, right? This one's ordered. Why is this one ordered? Because I've got it in the order of the rainbow. Red, orange, yellow, green, blue, indigo, violet. This one's disordered. This one's disordered. There are more, way more, that are disordered than there are that are ordered. And so, what it's saying, disorder, randomness, is way more probable on the scale of the universe than an ordered system, an ordered structure. Okay, and energy dissipates. So I've got up here, which of these is a more ordered state? Yeah, look at this one. Look how intricate it is. Think of the work that's gone into it. And if you leave that alone, if you were to leave this on the beach for a week, what's it going to tend towards? This. Will this ever randomly generate and form this sandcastle? No, it's incredibly unlikely. It could happen given an infinite number of tries, but you can see the universe moves from order to disorder. You see it here, you see it in yourself, okay? You as a human being, one day, every breath you take, it's taking you closer to your last breath. You're an ordered system at the moment. All of your organs function together accordingly so you can continue living. One day you're going to die and your body's going to disintegrate. All right, you're moving from a state of order to a state of randomness, a state of decay. The other way of explaining it, I said energy dissipates. If I bring a bucket of hot water into this room and we just leave it, what's going to happen to the bucket of hot water?
Cool.
It's going to cool down until, what, it reaches 0 degrees or It's going to cool down until
It reaches room temperature.
room temperature. It reaches what we call thermal equilibrium. They have the same temperature, they have the same vibration of molecules. That's all that heat is. And so that's, you can see energy dissipating. And we've said what's going to happen at the end of the universe, at the end of time. That is when all energy is equally dissipated throughout the universe. There's no matter left. Everything is burned up. Energy is equally dispersed. And time is pushing in that direction. Everything moves from order to disorder. The argument from order says order must be imposed by intelligence. I put it as a syllogism here. The universe is ordered. Okay? Premise 2, all order is imposed by intelligence. And the conclusion, the order of the universe is imposed by intelligence. So I can see some pretty obvious objections to this syllogism. It's a pretty poor syllogism that I've just conjured up. I was rushing to get it done before our lesson today. Anyone see? The argument, it's a strong argument. I've done a very bad job of the syllogism. Harry?
The order is that means without intelligence, like obviously we are logical beings and we can observe intelligence. That's saying without us there wouldn't be order.
Yeah, but like it's saying, like if we think of it as like an analogy, like we impose order on things, like I've arranged these characters in such a way so that it conveys something meaningful to you. There's an infinite number of ways they could be arranged, right? So that order required an intelligence to impose it upon it. Yeah. I think I might leave this one and I might chat to you guys about it as I'm moving around. We'll see if we can still man it. Vinny?
This is just an idea. So a beehive, right? Would you say that's organised?
Yes. Is a beehive an example of order? And so what would be, so is that an exception to this one? Are the bees intelligent?
Well, is our definition of intelligence like consciousness? Like a human's
Very good, yep, yep. So we would critique this argument by going after the definitions of what do you mean by intelligence? Does all forms of order require intelligence? Because you can think again, you can think of natural selection, right? A process which allows for complex phenomena to emerge, all right? A form of order, like the eye is an ordered system, your whole body as a unitary system working together is an ordered system. Has that arisen out of a simple law of the universe as such? Harry, got a bit of more input?
Yeah, just about the order and intelligence. Say you take something like, I just saw this bismuth crystals, and they have all that the perfect geometry with the squares.
Mm.
Would that count as like a bismuth crystal forming into this perfect geometrical shape?
Mm.
Would that be the order of that crystal? Like, would that crystal be order, but that crystal isn't intelligent, or there isn't anything intelligent creating that?
Very good. So here's the response to that, and I think the beehive one is that's begged the question against the argument, because the argument I've made here has asserted there is intelligence behind the order, right? There is something that dictates and makes these atoms behave that certain way, and so the reason these bismuth crystals form is because of the laws of the universe, because there is order imposed upon that system. Otherwise, it'd just be random. Sorry. Yeah.
But we can't prove that. We can't prove that it's not just random. Like, yeah.
So what about like why do things always operate according to the same principle? So this is like another way of explaining it. Every time I drop a pen, it's going to fall to the ground. This is an ordered system, right? There's something imposing order. There's something that forces the universe to behave this way. Why is it so regular in its behaviour?
Going back to the universe and the intelligence like that, well, like if you consider the Big Bang Theory, it just happened all at once. It was But there's also order in it because like all planets are in order, but like the intelligence of it, like we're saying, like because it's infinite in a way, because that's how we know it. So because we don't have infinite intelligence.
No. Yep. Yeah, so we're trying to assess these problems with a finite computing power that's in our brain. Yeah.
What does it mean by ordered in this context?